and welcome to section 11.1. We're just going to work with basic area formulas. It says areas of triangles and parallelograms. We're just going to see squares, rectangles, all that good stuff here today. A couple things from this slide here, and a lot of this is going to be reviewed for you guys. So area of a square, side length squared. Let's see. You don't really need to know this. If two polygons are congruent and they have the same area, it's pretty obvious. So you're not going to have you guys write that down. Area addition postulate. The area of region is the sum of the areas of its non-overlapping parts. What that means is, let's say you have like a rectangle and you have a triangle. You just add the two together. That's all that's saying. So again, you don't really need to write that down. And then area of rectangle, base times height. And then area of a parallelogram, also base times height. Please note that the height is this distance here, not h. This is not h right there. That is not the height. So keep that in mind. Generally, there's going to be a little right angle mark there to indicate that it is the height. Again, don't really need to know that. Just have this here. And then area of a triangle is 1/2 base times height, or you can do base times height divided by 2, your call. Basically how you get this is you take a rectangle or you take a parallelogram, and so like here, you have a triangle, it's base, the area of this right here is base times height, but you have two triangles, so to get one of them you just divide by 2. And you can do a very similar thing with the parallelogram, is you can duplicate or double the parallelogram, and then you can, or sorry, the triangle, not the parallelogram. You can create a parallelogram. This is just like one way of showing it. And so you have base times height, but there's 2 of them, so you divide by 2. So that's how you get a formula for a triangle, or it's a very like visual method. So here we have, find the area. We have 6 is the base, and it says it's a parallelogram, and 8 is the height. So you could do 6 times 8 as one method, or what you could do is rotate it and have the base be like that. The base is 12, then the height is 4, and for both, you get 48. So, you can do these problems in multiple ways. Just a few sample questions. I'll go through them kind of quickly for you guys. And by the way, the problems that you're going to see in this video are going to be generally a little bit easier. I threw some more challenging questions that involve like finding other pieces first. And so hopefully you get a little more of a challenge with some of these area questions. These are a little easier, I think. Let's see, so this one here, find the these want the perimeter and the area. Okay, so the perimeter, I guess we would just do 17 plus 10 plus 21. And then the area, we would do, this is 21, it's the base, 8 is the height, and then divide that by 2. Let's see, this is a parallelogram, so 30, 30, 20, 20, so the perimeter equals 60 plus 40. And then the area would be 30 times the height. The height is 17. Probably should cover up the number there. There we go. And then this one here, we do 5, 12, 13. It's a Pythagorean triple. You can do Pythagorean theorem if you didn't know it was 12. So the perimeter is 5 plus 12 plus 13. And then the area is going to be base times the height. I know this is the height because it's this right angle here. So 12 times 5 divided by 2. So there we go. Getting into a little more tricky questions here. The base of the triangle is twice the height. The area of the triangle is 36. Find the base and the height. So I'm going to draw a triangle here. The base of the triangle is twice the height. So if this is the height, all that x, and the base would be 2x. And the area is 36. So base times height divided by 2 is the area, and the area is 36. So those reduce, and we have x squared equals 36 when I square root both sides, I end up with 6 and negative 6. However, if I plug in negative 6 into the original problem, that would make those negative lengths, so I'm going to get rid of those. You need to buy paint so you can paint the side of a barn. A gallon of paint covers 350 square feet. How much should we buy? Okay, so this is a good one actually. Now, you might think, well, I can just do 26 times 18 and get the rectangle portion of it. Okay, well, that's easy. 468, and then we're going to add, so basically we have rectangle plus triangle. Now, the triangle is a right triangle, I notice. It's hard to kind of see there, but it's a right angle there. And then it's also isosceles, so it's a 45, 45, 90 triangle. The only thing they give us is, this is 26. So what you want to do is you want to use your 45, 45, 90 rule and go backwards and divide by root 2. Now, since we're just estimating how many gallons I need to buy, I'm not even going to actually, normally we would simplify that radical, but I'm not actually going to do that because I don't need to. So this is the triangle. I decided to rotate it so it's on its side here, and the hypotenuse. So then we have the base times the height divided by 2. Base times height divided by 2. That will give me the area of that there. So we're going to simplify this up, and it's kind of a fun problem to simplify. 26 times 26 is 676. Root 2 times root 2 is root 4, which is 2, all divided by 2. So what I'm doing is I'm kind of like following PEMDAS. I'm doing the multiplication first, what's on top of the division, and then I'm going to do 676 divided by 2. That's 338. And then I have this final divide by 2 there. So that divided by 2 is 169. And then I'm going to add that with the 468. And that leaves me with 637. So if I have to buy, if I have to buy a full gallon at a time, I need 2 gallons. Because I don't think the store is going to let me buy partial gallons of paint. So there you go. That's a fun one. All right, there's your assignment. Again, some of the questions in here are going to be a little more tricky. You're going to have to use you're going to have to apply some things from previous lessons in geometry. But if you have any questions, just let me know, and I'll be happy to help you.